I think Jonathan Paul will not agree with us. Just because what I need to spend 1 hour to just make it work.
Okay, I think we are live now.
Are we?
Yep.
Let's see. 1 second. Yeah, we're live. So basically, I'm going to share this link on our channel, and
We will
so
wait
everyone.
maybe like for 1 minute. 1 minute, not more.
Okay, we are live. Let's got some. So 1 minute, and let's move on. By the way, maybe you need to make a font slightly bigger because currently it's so
Yep.
huge.
Okay, no worries. I don't know, 24 can be too big. Or not. No, it should be fine.
Let's try and then we can fix it slightly.
Plus, we have like 180p, so it,
Yeah, but still. Anyway, let's try this one and we'll see.
yeah, I can look at my phone and it looks kind of okay. It seems to me.
So maybe let's start. So 1 minute is no, it's not. It is. Yeah, it is. So hello everyone. I'm Oleg, and here's my friend Bogdan. And today we would like to code something in Go, which is called runtime immutable checks. And basically, this idea appeared, I don't know, yesterday or
Yep.
a few days ago. Yesterday. And it's mostly a prototype. I think it's not a full featured product, but we'll see how it's going on. Bogdan, do you want to give like wider overview what we are going to code today?
Yes. So what we want to do is just like sometimes when you code in Go, basically there is no way to ensure that your structure is immutable in some sort, or that no one gonna change it after a certain period of time or so whatsoever. And what we wanted to do is just like create some library that will help users to verify that their immutable structure wasn't changed when you pass it to some other function or when you return it from your function and so on. So what I mean here is that let's say we have like a map of string to integer.
So they want to create some example and then
Yeah, I can try to show the example what I mean here. And let's say I added something to this map, so it's like mutable. So I wanted to have something like that. And then I call some function. Let's say external function. And I pass this map there. And I can't be sure that external function is not going to change my map. It can do it. It's totally legal. And what we would like to have is just like to be able to ensure that our function is not going to change, or our map not going to change. So if I create this function, and let's say here in M, I will add something more to this dictionary or to this map. If I'm going to print this, non-main package. Oh, it's not main package. We can make it main for now. It's not a problem. So as you can see, our map did change actually. And it's a problem for us. What we would like to do is just like somehow check that it didn't change. How we can do that actually? So one way to do that would be just make a full copy. So like if we go and we make reflect deep copy. Do we have actually reflect deep copy or something like that?
I don't think so. I know there is a deep equal for sure, but copy, I think maybe there's a reflect copy, which basically does such deep copy. But I'm not sure.
Yeah, I'm not sure that reflect copy does deep copy.
Copy the content of SRC into DST until either DST has been filled or SRC host. It returns the number of elements. DST and SRC each must have kind, slice, or array, and so on type. It's not stated that it is deep copy, and basically the name of this function doesn't give us such.
But still, I think people got the idea. So you can like make some other variable which is going to be copy m, let's say, and it will have the same type essentially. So it's going to be like map string int. Yep. Then I can. So this will be destination. This will be source. So I need to cast them to value. Yep. So like reflect value of something.
I'm not exactly, because DST and SRC params are values. I mean, like reflect values.
So let's check if we were able to make copy just for now. By the way, can you see the output of my runs? No?
Yep.
Yep.
No, by the way, no, because I'm looking at YouTube, not at the editor. Editor just shows me that you opened output, but still it's empty. So it's not syncing everything.
So it says to me that my reflect copy failed on map value.
Yeah, because you can copy slices and simple types from what I see from the code.
Yeah.
And there's no support for maps. And
that's even yeah, it's no, it's actually very bad. So what I need to do now at that point, I need to just like go to the GitHub, yep, find like Golang deep copy. I can actually I'm doing that already. I think people can see it.
I think I have found one by Batkimedes.
Reflect deep copy, reflect.
By the way, maybe we can do this via Golang binary. I mean this package gop. What do you think about this one? Because it's gonna be tricky, but still it should work.
New value of type something, then go through the all fields.
I think I was. It's fine.
Okay, so we have deep copier, and it should work, hopefully. What do you say?
Maybe.
Let's try it. So if I try to depend on it, and I'll sync my dependencies. If I use deep copier copy, M,
Basically, you are passing an interface. By the way, there's a deep copy function.
to copy M. That should work.
Ah, okay, deep copy or copy. Okay. And probably there's an error as a result.
Unhandled error. Okay.
Is it empty or what?
Yes, it's empty for some reason. We'll figure it out. 1 second.
Make a panic. Panic.
Okay, let's do that.
It's not okay. I got.
Yeah, we panicked. Error. So destination map is not addressable. So what if I do like that? Is it gonna work?
I think there's a problem because you need to pass a pointer to the map. Yeah. Yeah, nice. It works, but still not empty.
Yep.
Should be empty or not?
What if it's just because maybe I need to make these types the same? I never use this package in that regard.
Forgotten percent.
What options do we have?
No idea.
Options. Skip force field. Maybe we can look at examples of usages for this library. They usually use to copy paste basically to copy structs, but not maps. But it should be fine, no? Ding. Okay, so it's allocated and it should be.
So maybe let's check the code. What you're doing? You're creating a map, passing A as a key, making a copy of it, passing M to the external, and basically M is changed, but not the copy. Of course, copy M should have one. I should have one as a key. There's a comment which says allocate map with the make. There's no difference.
Yeah, we did that. So
I mean, yeah, okay. There's difference because by default map is nil, but with make it's not nil. It's empty. It's another thing. Sorry.
This is kind of strange. What if we just let's try struct. I'm just curious.
Just make a slice maybe, because it's horribly simple example to make a copy of slice.
I'm just curious at that point. I don't care. I was just like curious if it's gonna work or not. Okay, let's make slice. So let's make slice of ints. What if we copy m to copy of this slice? Okay, and I accept slice of ints here. And set something else into the first argument, into the first element. Okay, yeah, now it's a problem. So copy m is still empty. It's still not a full copy, which is strange. But what if I use reflect copy?
And reflect copy should work just because it's stated in the documentation that it works. At least it's promised that it will work.
Yeah. So my source is m.
I think it's destination source.
Yeah, and I should wrap it with reflect
Value of.
Value of.
By the way, this deep copier stands for this package is meant to make copying of structs. So there's no mention of slices or maps, even they are like, I don't know, the first capacity.
Okay, now it works. But as you can see, it's not so easy to do. Like we spend so much time to actually. Yeah.
Wait a second. Yeah, does it work? Yeah. Nice.
Yeah, it works. And now what you can do, you can just like create, let's say, a function that will check reflect div equal after you call it. Like you can do reflect, like deep equal, m and copy m, and then if, let's say not, then panic. And we can say in this panic, fmt sprintf, we can say that m something like that. So you can say m and copy m. Okay. And then it should fail and it should, yeah. Okay. And as you can see, it's not as easy to do. So what we wanted to make is just like a separate function that will work as a helper to do such kind of things. And what I
think one thing that we can mention here is just making a copy. It's not a cool thing because basically you need to traverse all this struct, all this map, and if you're pressing a pretty big map with some like constant map, just because you have something which you're not going to change, but still making a copy of million of items, it's not so cool. Still, I know it's like milliseconds, but still it's time, it's work, and CPU cycles and so on.
Mm-hmm. So we can say I wanted to have the following interface, basically. Ensure immutability, and it should, let's say for now, it will make this thing, basically. It will make a copy to copy M of whatever. We'll fix it in a second. And then it will return function that will check that nothing changed. Yep. Something like that. What we can do here is just we can wrap reflect value of. I don't work with reflection a lot, so I don't remember exactly the whole API, but it should be fairly straightforward. So we can say this is a value, target value. We can get target value type, and then we can allocate basically new. We can make a new string from it, no? Field value in
idea, but I can try to find something in the meantime, because I have got something like this in my personal project, and there is a way to create something like this. Basically,
reflect.
you need to make a set of
Make map, make channel, deep equal, copy, indirect value of.
I have something like this. I have sent you on Zoom.
You can actually edit my code, Oleg.
Ah.
Did you forget about it?
Exactly. I can. I'm copy pasting and it just removes what I have pasted. What? Wait a second. I cannot paste the code. It just removes it.
Yeah, it's very weird.
I can type when I'm making something like Command V. It just removes it and shows it removes it.
Just tell me how
Okay.
to do it. Like.
So idea was to make something like target value set of a reflect new of this type, which is
Okay, reflect new. That's what I knew.
Type.
That's what I need,
Yeah.
actually.
Yeah, basically you just you can create something like this, and here you need to pass a type of your thing.
Okay, I need reflect new of target value type.
Exactly.
It will be copy of value or value copy. I don't know.
And also I think you do.
And I will pass it. So this is gonna be my destination. This is gonna be target value.
Yes.
And like that. And then here I can check.
Wait a second. What are you doing here? You copy. Yeah, this one. Okay. That's even better.
And then
And also, I think you need to.
I can have something like defer ensure immutability of M. It returns function, and I'll call it here. And now that should work, hopefully. So it fails on copy because you can't copy something.
You know what? Reflect new returns a type value. And probably you need to run. Wait a second. I have an access for it too. I think you
Okay.
need interface here. And now it should work as expected.
No,
not
no.
like yeah, but you get the idea. I think you need to pass the interface here.
Here I need to do something. Value copy.
Interface.
Interface.
Yeah, that's what you know. I think so, but we'll see.
Nope.
Really? Copy of what?
Oh, maybe I need to do it like, okay.
Maybe you need to run that ptr or something. But I'm not sure why. Okay.
Maybe something like that. Is it gonna work now? Call of reflat copy on pointer value.
That's so. Copy on ptr values, I think.
Because this is the pointer at that point, no? This is the problem.
I think the problem because you're not passing pointer to the ensure immutability function. So
but copy works only on arrays, you know? That's the problem. On array or slice. It's not gonna work on anything else. That's the problem.
Yeah, that's true.
That is why I need to do some, like, we need to actually implement shallow copy thing entirely on our own to make it work. And that's the problem. So, but I think you got the idea that what I want to do is just like have some kind of thing that I can call before I pass anything to some external function. And then at the end of my function, I will check that it didn't change. So it's kind of obvious. The other way how we can use it potentially in the future is just like create some other thing, ensure immutability with finalizer, let's say. So it won't return function at all. It will just register a finalizer on my value of v, yeah, and check immutability afterwards. When the GC collects the value of when GC collects this value, we can check if it was mutated or not. And now the question is how we're gonna do that and how we can do it efficiently enough. And we have only like half of an hour to experiment with something like that. So my original idea was to do something like that. So we can like make a map of uint pointers. So what we're gonna do essentially is just like using reflection, go through all the references and all the objects inside our target value and make a copy of them, or just use some hash function to calculate the hash of the whole structure, underneath this value. In order to do that efficiently, we need to be able to find cycles in this tree, because it can be a tree structure or linked list that loops over its own values, like a ring buffer or something like that. And we're still gonna need this map to be able to resolve cycles. But we can use this map as well, so we can store here booleans and to be able to know like if we visited it or not. But what we can do, we can also store here hashes, and it will work as a checksum map of some sort, you know. So it will be like a snapshot or checksum. Something like that. And we can basically go over all values and populate this checksum map with data. And then in this function, in the callback function, we can go over the same structure once again and check if something changed or not based on the checksum. Hopefully it will work. I can see that you disconnected from my session. Did you?
Maybe. I think I will rejoin automatically.
Yeah, you rejoined. Okay. That's it. That's the whole idea. How we can do that. Now the question is,
are we gonna make it?
yeah. It should be relatively straightforward. All we need to do is just like now here, we can maybe split and look at some examples of reflection.
I think we can go. It's really easy.
We can go even to reflection copy and start it.
You know what? Give me a second.
So we can check kind, reflect value, target value. Okay. First thing that we do, we can check if it's null or not.
Okay.
If it's nil, we kind of return empty function. For now, this is fine. Okay, now we are here. We can have target value kind. And make a switch on top of it? What do you think?
Yep, can be. I think we can skip to, or like stick to just one type currently. We just don't spend time on also spend types. And maybe we can.
Yeah, let's make it work for our slices. It's for now. Like just
This is what I'm proposing.
Okay, so let's make if it's a slice
on the end 2, 5, 6. Yeah.
Okay, in case if this is a slice, then what we're gonna do? Let's check. Let's go back to copy. What they do. I think you can have the same function for array and slice, no?
I'm not sure because there are a few cases where array is not a slice in reflect package.
Mm-hmm.
I do not remember where, but still you can just get a penalty just because you have passed an array here.
Yeah, got it. Okay, so if it's a slice, we know exactly this is a slice. So we can maybe access its elements. And I think it's done via index.
Exactly.
And we can also check its length.
So
that's what we need. I think what we need to do is just have a separate function that we will use in recursion. So let's say capture function. It will call we can call it like capture checksum map, let's say. We will pass here actual map. Yep. Let's say uint pointer to uint64, and we will pass here a value, reflect value. Yep. And it will give us, let's say, new checksum. So this is the sign that we actually change it, basically. So we mutate. And here we can start to work on this stuff. So let's say we just go here. We have already target value, so we can switch on the kind of value. If it's slice, what we're gonna do, we're gonna make for for E,
it's valid, yeah.
and then we say value length, and then we say checksums equal capture value of checksums. Yep. And we say value dot index y, something like that. Okay, here we can make default, or let's make case for integers, no?
Yeah.
Reflect, do we have integer here? Yeah, we have int, that's great. If this is an int, what we're gonna do? If this is an int, we're going to
basically we need to pick up the address of our value and set it as a type, as a value of this checksums.
Yep.
You know what? I have realized that currently we are creating one entry in checksums map per everything.
Yeah, this is a problem. We can fix it later on. So we can say if this is a slice of primitive values, like if this is a slice of integers or and so on, then we're going to create like a captures the whole checksum of the whole slice of primitive values. But for now, we can ignore that, hopefully. What we can also do, I believe, we can use some unsafe magic as well if we want to. We can check like, okay, if this is a slice of what values, and it will, or what is the size of the value inside slice, and it will give us a size in bytes. We can then fetch address of the actual data array inside the slice and just hash it as a simple byte slice, you know?
This will work only for simple type.
No, it's actually gonna work for everything.
But wait a second, if you have a slice of maps, you can just pick up the hash of array underneath.
Yeah. I mean like for slice of anything, I mean. I didn't mean the maps.
Okay.
But
so
let's see. Let's do it like simply for now, and then we can work on it. So yeah, this is gonna be a pointer. So here, what we're gonna do? We can make a checksums view int pointer, and here we need to capture a hash of this int. Can we use hasher interface? for that?
Could
Map hash, maybe?
maybe.
Maybe no. Let's use
No.
map hash for now, and then we
No.
can decide on anything
I
else.
think it will work fine. So just
I just don't remember exactly how map hash works.
yeah, you need to create a hash variable before, and then you need to pass something to write function, I think, write method. And this is problem just because you need to convert everything to byte slice.
Now if I add something here, I can put bytes inside. Yep.
Exactly.
I can put only bytes inside.
Well, you can convert everything to string and basically write as a string.
Nah. That's...
Come on.
I know this is integer, okay? So what I can do is just like
Come on, relax. Just write it as a string. It's simpler for now. I know it's not so optimal, but there are a lot of different unoptimal things.
for now.
Yeah, for now, just write it as a string and leave it alone.
Okay. H. Right.
Write string.
String.
Ah.
Convert. Str
Yeah, exactly. No, it's okay. Just write it. Conf everything is fine. Your authorization does not work because you have HA on the next line and it breaks.
Yeah, I got it. Okay, I need to pass string here, so I have value.
And also you need to change a method on hash because it's right, not the right string. And
Not a
now
problem.
it should be fine. And also you need to convert your reflect int. Basically not a convert, just invoke int on value, and it should be int 64 from what I remember. So maybe I think add2e works with int 32. That's why I also need to use format int. So something like this. Yeah, I know it's horrible.
No, I need to use itoa.
Oh, it's itoi, sorry. Itoa.
Yeah.
Itoa. Esther config.
Format uint. Format int. Format int should work.
Yes. And now you can pass hash.sum into the checksums map.
Sum 64?
Sure.
Okay. We're not gonna... Let's capture error here and panic in case of anything. I don't think it's gonna happen, but still.
It will not, just because format int never returns an error, and try string should not return an error just because I think even there's no case.
Yeah, but for now we will lay out this thing. Okay, so now we just return checksums.
I'm just curious, is there an error for this?
And here, what we're gonna do is create a checksums map, wrap a target into value, and then we can call capture checksum, pass checksum map, pass target value, and reassign it to checksum map.
Bogdan, you
Yep.
can relax and remove this error check just because in the code price string never returns an error. And
Okay.
Same is right, the same is right byte.
Not a
So,
problem at all.
Yeah.
Okay. This is a checksum. Now, what we can do is here, we can capture checksum once again.
Yep.
So we can basically copy paste this here. We can do the same thing. It will be the same address, yes?
True.
Do we need to take target value once again? I don't think so.
Probably no.
Yeah,
Still
I
you
don't
need
think
to
so as well.
distinguish somehow.
Yeah, let's say.
No, you do not need, because you need to just compare checksums map.
Okay.
And the funny thing is, you can run deep equal on these maps. And
I can't run, or can. Deep equal supports maps as well? It should.
Yep. It should.
Yeah. So let's say that checksum map should be equal to new checksum map. To be honest, I would like to
say where is the problem.
Yes, but let's postpone that thing for now.
Exactly.
Okay. What if we just run this? Of course it's gonna fail on us. And it fails on this copy, but we don't need copy now. We don't need value copy. We don't need anything now. We're going to...
Also need to change or message. Nice.
Process finished with nothing.
Return.
So it didn't work as we expected, but now we can start to dig into that, yes? So we can capture, let's say here, let's just make debug printf and check what is happening.
Maybe you can add a new line between them.
Yeah, I'll do that. Yeah, good idea. So this is the new value. This is old value. Let's make new line between them. Let's say new. Old.
And let's run it.
So the map is empty, and it means that we
did something wrong.
failed somewhere here. We can start to use debugger at that point, I believe. So let's stand somewhere here and just run our main in debug mode. By the way, I'm not sure if you will be able to see my debug.
No, I don't.
Let's say, let's check.
Oh, wait a second. I see your debugger. It's nice. But but funny thing, I didn't see your output. That's fine too. So basically I can debug, but I cannot see the output.
Yeah. Okay. So, okay, this is the first call. We have a value here. Value of some type. And so on, so on. So let's move through it. Okay. It's not slice. It says that it is not a slice and it's not an int. That's the problem.
Yes, I think it's a pointer to a slice. That's why.
Yes, you are true.
Maybe you
Let's
can
remove it
and
now.
see will it work. And I'll be pretty happy if it will.
Or maybe we need to actually start support pointers, because you can't pass. Yeah, it's not a problem. We can support pointers. Why not?
I also thought about that, and there is a special for loop for this kind of thing. It's reflect PTR.
Okay, if it's a reflect pointer, what we're going to do, we can hash its actual value. So like we should know that it didn't change, no?
I don't think so, just because it's about pointer, not about its value. I think we're also interested in the value of this pointer too. That's why I thought about something like, can I type something? It's like value element, which will give us underneath element underneath.
Yes.
And then we just need to run.
You can copy paste this line from here entirely.
Basically, yeah. It is.
Okay.
And I think that's all what we wanted to make here.
Let's run this one.
There's a problem.
So it fails here because we are trying to call value pointer
on a simple integer, but there is no pointer of itself. So that's why we need to convert. I'm not sure how to make it properly. Probably.
Well, we need to actually do some kind of like interface or something like that and get the pointer from it.
I think, Bogdan, it's simpler to change our case for electric slice and just to iterate all the integers. Let's assume we have only integers for a moment. And when we have we want to calculate hash of integer, we just convert it into int 64.
Indirect. Okay, so let's say it can work. So what if we just say value? Can we ask what is the subtype or type of its values of?
I think it's also called element. I mean element, which gives you type of this element. Or maybe you need to run like value type element, and it will give the type of the element, something like this.
No, it will panic if it's not interface or pointer.
Wait a second, I have a code which looks like... I cannot copy paste. Okay.
What I can do is just here, when I get item by index item, then when I have this item, I can check what it is. Once again, it's like one additional switch.
Agree. But okay, yeah, it should work.
Item.kind, and here I need to support reflect int. Yeah. For this thing, I will need to use item. Here I will need to just continue to write it down up until the end of the for loop. Yep.
Sounds good. So basically,
yes.
Just adding.
So we add, and now here we just put the hash into value pointer.
What? Wait a second. I think.
And value pointer.
To also write.
value pointer
Wait a
will
second.
will
Is
work
that
for.
Yeah, agree. Everything is fine here. There's only thing you do not need this run on line 32 because it's obsoleted. Yeah.
Yeah.
I wanted to propose you also to write a length of a value to the hash, to a hash. Just because there is, I'm not sure because we know that there are collisions for all possible values in the world. But even adding a length of a slice should help us just because we have less chances.
Okay, and it worked.
Wait a second, I didn't see output. Oh, I see. So that's cool. Now let's remove this change. I mean, place it to here and run it. And it should not panic, just to verify that it will. It's deterministic.
It still panics. Okay, let's remove external at all. Remove any change. Yeah, it still panics. So the problem.
I know why. I know why.
Mhm.
I think I know why. Just because here we are creating a new thing. No, it's not. That's interesting.
So I can see that uint pointer is the same. So this is fine. The actual hash value is different. This is not fine. And it can be because map hash is not suitable for us, because map hash has its own seed. So if I set a separate seed.
No, wait a second. You can just set a constant seed like.
Yeah, I'll gonna do that. Map hash make seed. Make seed. Let's say it's a seed. Then
I completely forgot about seed just because. Make seed. Make seed just returns a simple seed.
Oh, I got it. So I can use the same map hash. I just need to
run invoke method which is called setSeed with some constant value.
h dot set seed.
Exactly.
And now I need to have map hash seed.
What?
And I set a value here.
This. I don't remember this API at all. Oh, this is fine. I think I know. You need to create a map hash seed as a global variable, which will be constant. And then you just pass it all the time to the hash.
Not a problem at all.
I agree, it's not a problem, but still, it's funny. And here it's make seed. Yeah, true.
For now, it's gonna be fine. Right. Use of uninitialized seed. Okay, let's say.
Wait a second, just because I thought you had type make seed. Yeah, now it should work as expected.
Yep, it works. It works for our super extremely narrow case, yeah. But we already spent like a little bit of time on that. What we're gonna do now is just we can expand this and make it pretty. It should be possible, I believe. So next time, maybe we're going to support more different stuff in the slice, let's say, that make maps work. And then structures and so on and so on.
And one thing that I would like to make is to hide it behind the build flag, just because you do not need this all the time, but still you can leave it in the code
Yes.
and run it only with a special flag like check immutables or with a minus raise, which also, or with a check PTR, which does different checks during runtime. And it's not so hard to add it, just because I'm not sure regarding the returning function from ensure immutability. It can be nil or it can be simple func, but I'm not sure will compiler
we can check it later on. It's not a problem. Even
Okay,
if compiler is not gonna remove it, it's still gonna vanish all the overhead almost. We'll see. I believe we will be able to overcome this issue. It's not a problem. The other problem is that with VR reflection, you can access only public fields. It's kind of fine, maybe not. We'll think how to deal with it later on, maybe. I think like if you're trying to protect your data from some other code, you usually know what you're gonna do in your code. So if you want to protect something, it's against some other code base, like library or whatever. And this library shouldn't be able to access your private fields.
But suppose you have a method which is like called setSeed, which basically change something underneath, which is not exported.
No, you know, it's fine. Like what we can do then is just like, okay, say that I'm going to do like that.
I agree.
I can establish ensure immutability on different private fields as well, if I'm super cautious, and so on. So it can be over. We can do it. We can also use like our knowledge of the internals of the runtime to overcome it, because in general we can actually implement all this stuff without reflection. Actually, if we can talk about this next time, since yeah, we have only 1 minute left till the end of the session.
Okay, that's cool. So let's finish for today and see you later, maybe in a week, maybe in a few weeks.
Yeah, hopefully in 1 week.
Yeah, okay, so feel free to leave a comment here under this video, or maybe join our Telegram chat and leave your questions or proposals for the future. Thank you, all of you, and see you soon. Bye.
Yeah, sorry. I think we can also, sorry. We can make an organization on GitHub and publish this code in a separate branch, which is going to be called like day one or something like that. And then we can publish different branches for every session that we do. So people can follow us in the code base and so on. What do you think?
It's done almost.
Mm-hmm. Okay, then see you soon.
Yep. It's called God Battery Reviewer. Nothing else.
Okay.
As it can be. Okay, bye. So feel free to stop stream.